Hello everyone, welcome back to Microsoft Student Chapter VIT-AP University's official YouTube channel, and here we are with a brand new video on the topic interfaces. So in the previous video we covered abstraction, and coming to interface, it's just a special case of abstraction. It also does data hiding. So like, why do we need interface? Need for interface? It because it provides 100% abstraction. Now, while we discussed abstraction, I had mentioned that it only provides partial abstraction. Why? Because it can contain both abstract and non-abstract methods. Means you can write the function body, that also works. If you don't write the function body, that also works. Like if you can define both abstract methods and non-abstract methods. Whereas in interface you can have only abstract methods, which means if you try to implement the function body of inside any interface class, it will raise an error. Why it will raise an error? Because interface methods are public and abstract by default, which means the compiler itself set the access modifier to public, and the keyword abstract is also added to the interface method by default by the compiler. That is why it can have only abstract methods, and if you try to implement the function body, it will raise an error because of this. Now, as just like abstraction, this interface also cannot be instantiated, and we cannot create the object for interfaces. And the next point is inheritance is mandatory. Why? Because in we can write only abstract methods in interface. So if the compiler needs to understand what the method is, the method should be written somewhere inside the code. So for that we need a child class inside which we'll write all the defined methods, all the methods of interface class write inside this child class. That will be a normal class. Inside that we'll write all the method names and its implementation. So because of that, inheritance is mandatory. And also, the interface variables must be initialized at the time of declaration. Initialized in the sense they should be given some value at the time of declaration itself, because interface variables are public, static, and final by default. So when we discussed about access modifiers, you might have heard the keyword final. What does that mean? Final means if you define a value to a variable, if you define a value to a final variable. For example, if we define a final variable, for example, final a equal to 5. So in this case, we have assigned the value 5 to the variable a, and because a is final, we cannot modify the value of a further. So means if we write if we in some other place, if we write a equal to 10, then it will raise an error because this a is final. So once you define the value of the variable, it cannot be modified. The variable value cannot be modified. So the interface variables must be initialized at the time of declaration itself, because it will be public, static, and final by default, and this is also done by the compiler. Okay, now we'll see classes versus interfaces. So this is basically in the previous slide I told that inheritance is mandatory for interface. So for inheritance we have both parent class and child class, right? So here we'll see how a child class inherits the value or the properties of parent class. So if you see here, these are the parent classes, the one at the top. These are the parent classes, and these are the child classes. These are the child classes. Fine. So if both parent class and child class are normal classes, this class means normal class. It's not an abstract class or not an interface. Okay. So if both parent and child are normal classes, then we use the keyword extends. So if we have a class A, for suppose class A and class B, okay, these are normal classes. So class A, this will be the parent class. This is the parent class, and this is the child. So how do we inherit the values of A? We write extends A, right? So this is the case when both parent and child are normal classes. Now what if now we'll move on to the second case. What was the second case? When the parent class is an interface and the child class is a normal class. So how do we define an interface? We'll see. For that we use wait. So for that we use the keyword interface. So if you want an interface A, we'll write interface A and we'll write the data members and member functions here. And here if we have a normal class, for suppose class B. Okay. And now this B needs to inherit the properties of A. For that we use the keyword implements. It's not extends, it's implements. Implements A. And here we write the body. We write the contents of the class. So that's a key point here, that if a normal class is inheriting an interface, we use the keyword implements. And the third case is when both are interfaces, like both parent and child classes. If both of them are interfaces, then we use the keyword extends. So for example, if we have here we have interface A, and here we write if suppose if we write interface B. Now both child and parent became interfaces, right? So interface B, here we will write extends A because both are interfaces. Because both are interfaces, we use the keyword extends. If this was a normal class, then we would have written implements A. So that's about classes versus interfaces, like how we inherit the properties of interface classes. Okay. Now this is basically a like difference between abstract class and interface. So for abstract class we use abstract keyword. For interface we use interface keyword. An abstract class can contain both abstract and non-abstract methods, whereas this interface can contain only abstract methods that I mentioned in the like in the beginning itself. And in abstract class only partial hiding of data means partial abstraction, and here we have complete hiding of data means complete 100% abstraction in case of interface. Now abstract class does not support multiple inheritance. Now what do you mean by multiple inheritance? If you have a class A, a class A, if you have class B, and if you have class C. Okay. Now if this class C wants to inherit the properties of both A and B, how can we do? If these are normal classes, then how can we do? Then we need to write class B extends A. So what happens here? Class B contains both the properties of A and B. Now class C extends B. So in this case what happens? Class C extends B and B contains both the properties of A and B. So now class C contains both the properties of A and B. If you write class C extends A comma B, that won't work. Class C extends A comma B does not work, it will raise an error. This is called multiple inheritance, when a single child is inheriting two parents, like more than one parent, then it becomes multiple inheritance. So that is not possible in case of normal classes or abstract classes. This is possible only in the case of interface. So if we have interface A, interface B, and if this is a normal class, then also it will work. Class C implements, it's not extends, it's implements A comma B. This is correct. So that is what is meant by multiple inheritance. Okay. Now extends keyword is used to inherit an abstract class, right? That I explained the previous slide itself. And here we use implements keyword if a normal class is inheriting an interface, and we use extends keyword if two interfaces are inheriting each other, like a child class is also in interface and parent is also interface. In that case we use extends. In all other cases we use implements. So that's all with the theory. Now we will see a code. So here we have an interface A. It has a method void display A, right? So even if I write void display A, the compiler automatically by default puts the public keyword before it, that we can't see, but in the backend it's happening. The compiler makes this method public by default. Whereas in normal classes, what happens if we write void display? If we write void display in normal classes, then the access modifier here will be default, whereas in interfaces it will be public. This is put by the compiler itself. Compiler does this by default. Now similarly we have interface B, which is extending A. Now these both are interfaces, so extends keyword came. And we have void display B. This is also again public. Okay. Now we have an interface C, which is having a method display C, void display C. This is also public by default. Okay. Now we have a normal class interface demo, which is implementing both B and C. We extended this B with A so that now B contains both the properties of A and B. And I wrote a method like I wrote an interface C. Now if I implement these B and C, automatically all the methods of A, B and C becomes accessible. Okay. Now inside this class, I have written all the method implementations. So here's the method implementation of display A, here is of display B, this is of display C. And it is printing like interface A inherited, interface B, interface C. Okay. Now we have a public class test, a main method. Inside that we write interface demo D equal to new interface demo. Now why didn't I write interface like why didn't I write A equal to class A? I create an object A equal to new A, because interfaces cannot be instantiated. That is why we have to create a child class for making the object. Only with the object we can uh, access the methods, and inheritance is also mandatory for interfaces. So we use this child class as to create the object, and using that object we define or we call all these functions, all these methods A, B and C. Now let's see what the output will be. Now here if you see, we have an interface C, right? An interface like interface A, interface B, which is extending A, and an interface C, just like how I explained the like in that slide. And now this is the same code. Now let's try running that. Now if we run that, we will get interface A inherited. This was the display A. Display A was interface A inherited. This was interface B inherited. Means that was display B method, which is there inside interface B. Now we and the next is interface C inherited, which is display C present inside interface C. Okay. Now this is one case. Now what if I try to create an object for one of the interfaces? So if I write uh, A, if I create an object for A, now here itself it's raising an error. What's that? Uh, no, that's a syntax error. Let's see. A obj equal to new A. Okay. Now if I write uh, obj dot display A, so what it will print? See, A is abstract, cannot be instantiated. So if you see here, we don't see any error. Why? Because syntax wise it's correct, but when on runtime, it will check whether this class is there or not. If this class is there, so this is an interface, so it cannot be instantiated, and it is raising an error here. So that's all with the portion of interfaces, and the next video we will see packages. So that's all. Thank you.